Oh, I'd love a Guinness. J'ai joué au foot. Hagen, Flagen, Schlagen. Things that I am really not good at. I can't do languages, and turns out I also can't do accents. Beer can sandwich. I just can't do it. Anyway, there are some things that I can do. This is episode 3 of learning stuff with me. So come with me, and we're going to learn how to use the hash that we previously captured using Responder.
It's time to learn stuff with Yekki.
So what we're going to do is we're going to jump straight in with creating a bespoke word list. We're then going to use that word list using both John and Hashcat to crack the Responder hash that we captured in episode 2. So hopefully you followed episode 2, it all made sense. You've got a hash from Responder, so we're going to use that. So if not, go back. It's on my YouTube channel, it's on my blog. Everything should be straightforward to follow. So first up, what we're going to do is create a word list. Now the domain is Doctor Who themed. Everything about this is Doctor Who themed. And I imagine that the password will also be Doctor Who themed. So what we're going to do is create a bespoke word list that is Doctor Who themed. So the idea behind this is it works really well. Lots of companies will use passwords that are related to their business. There'll be the company name, hopefully not. But there'll be kind of things that a common Google search or a word list will be able to help you crack some passwords. So we're going to use a tool that I cannot pronounce. It's either cool or cruel or soul or I just don't know. But it's CEWL. It's built into Kali, so it should be there for everyone. If not, there is a GitHub page which I've linked to in my blog. So if we do tool cruel-h, we get the help. So thanks to Robin Wood for picking a really stupid name. I'm sure it does make sense. And what it's got is it's got quite a few bunch of options. But the idea behind this tool is you give it a URL, it goes there, it scrapes the page, and it comes out with all the unique words. So it gets rid of all the duplicates. But what it can also do is it can go deeper into websites. So it can follow hyperlinks, it can follow kind of information that it finds, which is amazing. So you can say depth of 7, and you can go 7 layers deep in a company's website, getting all of the unique words. This will make a huge word list, which is really awesome. So what we're going to do is we're going to use that, and we're going to do Wikipedia, Doctor Who, and Rose Tyler pages. So I don't want any depth in these because I don't want to download, the whole of Wikipedia. That would be too much. So we'll start off, we'll go crawl, D, a depth of 0. Now the next bit that's really good here is -m, and this is the minimum word length. So the default is 3. So what this does is it gets rid of on, a, an, in, all of those kind of small words that are very unlikely to just be a password. I mean, they're not going to hit the required level of passwords and all. It's all just a bit silly, so it gets rid of those, which is great. So we're going to do a minimum level of 3. We're then going to do, we want to write the output to a file, so we're going to do -w, and that file we're going to call, we'll call the first one doctorwho.txt, and then we just need to give it the URL. So I am going to do Doctor Who Wikipedia, just getting the old page up on Google, and there we go. So now if I do that, it's done it. It's literally, that was what, 4 seconds, and it's done it. If we do a word count on there, we can see that it's got almost 5,500 unique words off that one page. I mean, that's just bonkers that quickly as well. So we'll do the same thing again, but we'll do the Rose Tyler page, considering the user that we cracked the hash, we captured the hash for was Rose. We'll do her own page because there's bound to be more words that are significant to to her character within the show. So I just need to make sure I get the right one. Rose Tyler, here we go. So there we go. Right, again, it was even quicker. That's insane. So for that we got just shy of 3,000 unique words that are over 3 letters long. So what we want to do is we want to make one word list because we've currently got 2, which won't be any good for cracking. So we'll go Doctor Who into wordlist.txt. We will then do cat Rose Tyler into wordlist.txt, We'll then do a sort by unique, just to get rid of any unique values in word list, and we'll stick that into unique word list. So what that will be doing, even though CEWL gets rid of the unique values, there are going to be the same words over the 2 Wikipedia pages that we downloaded. Fortunately, the tool I don't think does multiple URLs, but you know, we can work around that. That's fine. So now I've got a unique word list, and this unique word list is already 6,624 lines long. Like, this is insane. So if I do a grep for Cyberman within unique word lists, it's not there. I don't know why. There it is, because it's capitalized. So we've got a hit. That's great. Is that the password? It's not. But you know, it's really good. Now, Rose is pretty smart. You know, she did loads of stuff. She stared into the heart of the TARDIS. She ran away from aliens. She got stuck on another dimension. She was pretty smart. So I don't believe that she would have a password that is just a plain word. She's going to have some leak speak or some characters or, you know, something, some numbers maybe after her password that will be part of it. So what we're going to do now is use John the Ripper, which is primarily a cracking tool, but we can use it to mangle word lists to add in different variations. So if we do John help, we can see that it's got this called the rules. Now there are, I think it's 5 different rule options. There's single, there's 4 others, and then there's all. Now I ran all before and it took over an hour, and the output was just absolutely obscene. The word list was huge. It was absolutely massive, which is amazing because it just mangled the word so much that any password that was likely to be was going to be in there. But I don't think we're going to need quite that level. So we're just going to use, there's one called single, which we're going to use instead. So we're going to say rules, John rules equals single. We then want std out, this one, which is just output the candidate passwords. So this will, rather than using it to crack, it will kind of create an output. I think I need to put 2 things in there. And I also need to give it the word list. So I need to do word list equals, and we called it unique word list.text. We're then going to do that to John word list. So we're going to output that directly to a file called John word list, which we can then use to try and crack it. It didn't like that because I had a capital. So let's do that. It's done it. That was so quick. It's unbelievable. Tools are amazing. So if I do a word length count on that, we've now got over 5 million words in what? 4 minutes? 5 minutes? This is obscene. This is like the quickest thing. It's crazy. So now that we've got that, we can do, let's do our grep again. So we want to do the grep for Cyberman this time we're going to do it in John word list. Look at how many there were. I don't know if you saw that as it scrolled past. But there's all of these. There's all the numbers, there's symbols before and after, there's different capitalization, there's other letters, there's doctor, there's Mr. You know, this is just the simple word list, the simple mangling of this word list, and it's come up with so much stuff. But it's done this for every single word. Absolutely bonkers. Really freaking love it. So now we've got an awesome word list. So now we can try and crack it with John. So I like John. John is straightforward. You give it the word list you want and the hash file, and it works the rest of it out. It works out what hash type, it works out everything else, and it tries to crack it. So to use John, we do John word list, and we're going to call this unique. I can't remember what I called it. Let me just do an ls. It was unique word list, so we'll do John word list equals unique word list.text, and then we're just going to do the hash file. So this is the hash that we captured with responder in the last video. So rosehash.text, and it has somehow it's run through that unbelievably quickly. That might be because I've already run through it. If I move rosehash to rosehash 2, okay, it does it. But what John will do is if you do John -- show, it will show you the cracked passwords. Now, sadly, it didn't crack our password. This is my fault. If I go back to our unique word list, if I grep for bad wolf, which is the password but with some kind of stuff in it, in unique word list, it's not there. So it was never going to crack it because it wasn't in the original list. But let's fix this and let's change our password. So now we've got 3 hashes. We've got the original one of the password that won't crack because it's not in our word list. Now hopefully one of these 2 will be crackable. Let's give it a go. So instead of just going up, let's do the command again. So we want John word list equals if I just go up, I know why it didn't crack before. Because I used the wrong word list. I didn't use the mangled John word list. I just used the unique words. So that would make sense. So if we do word list equals John word list text, then rows #2, this now runs through. And there we go. We've cracked 2 of the hashes. Why they're different, I don't know. But we've got it. So the great thing about John is if you've got hundreds of hashes, you're not going to be able to kind of keep track of who it was on there. But if you go John -- show and then the file that your hashes were in, it comes up with the hashes, with the user, the password, the domain, and then the hash and all the stuff that you put in. So we can see that Rose's password is now Mickey1. Mickey obviously being the love of her life other than the doctor, which probably not an impossible password in a big domain organization, someone's other half with a 1 after it. Why not? So that's great. Yes. So now we've got a user, we've got a password. We can now do kind of other things on the network that gives us a foothold, and we can look at if we can do crap map exec, can we spray that password? Can we do Bloodhound and try and understand the domain? And we'll look at all those in the next few videos and kind of go through what the next steps from here might be. But I did promise that I'd show you Hashcat as well. Now Hashcat is, I think it's more powerful than John, but it's a lot more complicated to set up. So if we start with Hashcat H, all of that is the help. It's bonkers. So let me just find the top of that. Should have piped it into more, that would have worked. But so we do Hashcat options, the hash file, and then the dictionary file. So there are a few options that we have to set. So with Hashcat, you've got to set the hash type, which is -m. So for us, that'll be a net NTLM v2 because it's the latest NTLM Windows stuff. Then we also need an attack mode. Now, if we scroll down slightly, for the -m, for the hash type, we've got all of these. So we'll do a grep for NTLM in a little bit. But then we've also got attack modes. So you've got straight, you've got combination, you've got brute force, you've got like all of these do different things and allow you to try and crack the password in different ways. We're just going to use a straight word list. So we're just going to use attack mode 0. So to do this, we do Hashcat attack mode 0, 0. Sorry, attack mode 0. Then we need to find out the hash type. So we need to go Hashcat help grep NTLM. And let's do that in case insensitive. So there we've got NTLM v2. So we can do 5600. So let's do Hashcat attack type 0 for straight attack. Attack type 0, hash type is 5600. We can then do an O for the output file for where all of our cracked passwords get put. So we'll put Hashcat cracked.txt. Then it was the hash file and then the word list. So here we're going to go John word list. And it won't run because we're running on a VM and we don't have a dedicated graphics card. Hashcat will kind of throw a bit of a fit because there isn't a device to use to crack it with. But we can fix that. If we do --force, it will then run. And it does a load of stuff. And we can see that we can get a status. So it has somehow exhausted the word list, which I don't think should be true. If we go cat hashcat cracked, it did crack them. It just, normally I thought it would have come up as, it didn't come up as complete because there was still that one hash that it couldn't crack, which was the first one. So it came up with exhausted rather than completed. So that's what I got confused. But here, again, the same as John, it gives you a nice output where you've got the user, then you've got the details kind of you put in, then at the end it's got the password. So we've got the password of Mickey1. Brilliant. So please send me any comments, send me any questions that you're interested in. I will be looking at how we can use this password in future videos. If you kind of think there's anything that you'd like to learn, you'd like me to explain, please just let me know and I'll try and do my best. As always, there's the blog that goes along with this, and the description of that will be in the comments, in the description even. Please like and subscribe, leave me a comment, hit me up on Twitter. All of these, any feedback I get is really appreciated. Thank you very much. See you next time.